screen, that'd be great. Thank you. Okay, so Koji's a really big topic. It's something that perhaps it's not really common in Western culture to hear about it, but it is injected in so many different things that we find familiar, and that are, you'll notice that, yeah, it's just such a big world. So I'm going to go on a lot of tangents. I'm going to try to highlight some of the main points. I'm going to try to not info bomb you, but at the same time show you the diversity of information around this topic. So just get a raise of hands, like in 3 different levels, how much you know about Koji. Maybe never heard of it before. Okay. Maybe like have kind of heard about it, but know what it's part of. Sweet. And anyone's like grown it before or made anything with it? No. Wonderful. Okay. So yeah, our goal is to change that, and so here we go. You mind going ahead? Okay, so we'll just start right away with what actually Koji is. And I actually have some here to show you guys. We'll probably open that up later. But I just started some off a couple days ago, and here it is. It's a mold, but it's been domesticated. And not only has it been domesticated, it's one of the first things humans have domesticated. So about 9,000 years ago, right around when barley and grapes were being domesticated in the Middle East, in the Henan region in China, we'll get to this later, Koji was being domesticated. Someone realized that it could have a really cool application for fermentation, and so they started taking it, growing it, and furthering it to a point where they've selected for a Koji that is non-toxic. A lot of Koji's cousins and relatives in the wild do produce some mycotoxins, which are not good to be consumed. And so another cool factor about Koji is that the reason it's white is actually bred to be an albino species of that mold, so that you can actually show if there's contamination. It's way easier to spot contamination because it's been bred for that. So some argue that has some flavor impacts as well, but that's just some nuance. Aspergillus oryzae, I think we can skip ahead if you don't mind. So just to take apart the etymology of the word, aspergillum, holy water sprinkler, and that's because if you look at it under a microscope, the conidia, which are these reproductive organs of the mold, they look like a holy water sprinkler. So this is clearly back in the day when the church was funding a lot of what was science. It just happened to be an object close by that looked like it. So, all these Latin names can be a good way to universalize it so we know what they are, but they're also just kind of littered with culture, and it can be a good thing, but it can also be a bad thing. That's just for another day. Oryzae, that's about rice. Latin name for rice is Oryzae sativa. Sativa, you may recognize that word. That just kind of means cultivated. So you'll find other plants that have that. Not to get too specific, but someone hears that, it's like, oh, but then you'll start finding a ton of other plants that are sativa. And another tangent that I will not get into. Okay, you can go ahead.
We got that on video.
Yeah, we sure did. Okay, so we're going to back up a little bit, quite a few million years, to explain more or less how we're related to Koji. And I think this is really an important message to just remember again that we are related to all the life forms that are out here. We may look different than trees, we may look different than mushrooms, but we are genetically intertwined. And so if you take anything away from this, it's that when the tree of life was splitting away, plants split off before animalia and mushrooms. Animalia and mushrooms actually evolved together for quite a few million years before splitting away from each other. So that means that we're related to mushrooms more than we are to plants, right? So we inhale oxygen, exhale carbon dioxide, mushrooms do as well, right? Koji does that as well. The main split happened, however, is how we digest things. So whereas animalia started digesting things internally, fungi started digesting things externally. And so what Koji does, for example, is it puts out its digestive enzymes on the external part of its body and essentially grows into its food. Whereas we put food inside us, Koji puts itself inside its food. It's just, and you'll see that. I think it's just important because we'll realize that those digestive enzymes are what we're actually leveraging when we're using Koji in a culinary context, or in a lot of different contexts actually, but we'll get to that later. So yeah, that was it for there. Let's see if we're missing anything there. No, we're good, let's go ahead. Yeah, so this is gonna be approximative. There's so much history to Koji I like to just preface with it. I'm just giving a slight window into the history of Koji, and I want to honor it by, hopefully exciting y'all enough to go and dig deeper yourselves. So yeah, let's talk about Koji just at the beginning in the discovery. So, as I said, it was found about 9,000 years ago, 7,000 BCE in the Henan region in China. They discovered these clay pots that had residue of this drink that had Koji, honey, fruit. It sounds delicious. And it was happening a long time ago, and which is really cool. And essentially, why did they gravitate to Koji? It's because it actually created a clean drinking source. And we'll actually get into that later. That's a later slide. Oh yeah. Let's see, what am I missing? Again, one of the first things we've domesticated. When people are afraid to hear, oh, mold, oh my gosh, we're going to work with a mold. It's been worked with for thousands of years. Humans have interacted with this for such a long time. That's the main lesson here. Okay, you can go ahead. So this is a little exercise to explain what Koji is actually doing. So who's fermented alcohol here? Okay, sweet. So we'll know that with grapes are wonderful for fermenting because they have a ton of sugar. They're already just so juicy, that sugar turns into alcohol via fermentation, anaerobic fermentation specifically. With grain for beer, anyone done beer? Okay, so what do you need to do to the grain to make it so that you can ferment it? So there's like a first crucial step, which is you sprout it, and then you cook it. And that's because it's releasing this amylase enzyme that's helping turn that starch more into sugar, and so you can have a sugar input for your beer, giving it more alcohol. And so that's what they figured out, really in what is nowadays kind of like, or what was Babylonia. And what's really cool is that they totally took a different pathway to this same thing in China, which was they used the Koji. The Koji excretes that same enzyme, amylase, that turns that starch into sugar. So that's how you can get sake by pulling sugar out of starch, which is really, really good if you're trying to, ferment something. Sugar is essential, and it's not like they had like processing plants for cane sugar and all that was really accessible. Coaxing sugar out of stuff was hard. That's why fruit was so valuable. That's why people fermented that so often. So yeah, this is just kind of like a parallel of how it was used in the different places of the world. Any questions? Sweet.
It's really great sound. It's steaming.
Okay,
When
sweet.
do you want to put that in?
Yeah, let's talk about that. So we're going to get a little ahead of ourselves right now, but for the sake of the presentation and for our exercise later, we're going to start steaming this rice. We'll go through the whole process later, but it takes about 45 minutes to steam. We're doing rye today because it's what I had.
Oh, fun.
Yeah. And just really simply, and again, we'll go over this later, I'm using this cloth to kind of hold that rice or barley in place. Oh, forgive me, rye. Oh my God, some grains. This has been soaked overnight, about 12 hours room temperature, and that's just hydrating it. And what we're going to do is I'm just going to put it in here, and we're going to let it steam for 45 minutes. We'll talk about why that's important later, but it's good that you just see how we do it. Alex is probably going to stir this maybe 2 or 3 times throughout, just to make sure it's even, and then we'll approach that later. But it'll just be good for you to get the whole context, and it's certainly like stretched out time-wise, so thank you for the little tangent.
How often should you stir it?
Yeah, it'd be like 15 minutes. It also depends like on your steamer. If you have a really big white steamer, it's getting steamed more evenly, and so you don't need to steam it as much. If it's really deep, you might want to steam it once or twice. The idea is to just have it homogeneously steamed, so something that's this deep, maybe 3-4 inches, I would steam stir it 2 or 3 times throughout.
There's a steam basket inside.
Yeah, there's a steam basket inside, there's water boiling underneath. Do you mind actually scraping the rest of that in there? And then we're going to want to close it again to help like the even steaming. We all know how to steam something, but yeah, just to make sure we're covering the basics. Okay, so we kind of touched on a lot of these things already. Again, the relatives produce toxins, and so this was like, it took hundreds, if not thousands of years to refine a culture that was non-toxic. And they kind of did this through selection, much like you would select for a kinder puppy or dog. You actually select for Koji that yields the best fermentation. And so the better the fermentation, the less toxins are in there inhibiting that fermentation, less toxins are in for us. And so they just picked the tamer Koji continuously until they essentially bred one that was void of toxins. This is totally FDA approved right now. It's not something that we have any questions about. It is does not have toxins in it. I have to say that a lot because it is a mold. A lot of molds do have toxins. Cover the top. Yep. I get that even steam. All the way down. Yeah, that's good. There's going to be some airflow. That's fine. We're going to talk about why it being used for fermentation is so important just in a second. We've done everything here. We can go ahead. Okay, so this is why it's so important. Because ever since, this is about like maybe 10,000 years ago plus is when humans really started polluting their environment. It's really hard for us to not do that. It's kind of like the whole like cloaca massima that the Romans invented to funnel our waste away. Massive invention as far as like sickness and stuff. And so either way, we've been ruining our water table this whole time. And having a place where we can actually ferment something and guarantee a safe drinking source is super essential. And so finding a source of sugar that wasn't as a little more consistent than maybe fruit that only comes a certain amount of time and that you can grow in really high quantities, that rice was providing that starch source, the Koji was coaxing that sugar out, and then they were fermenting it. And essentially everyone was drinking fermented products. Babies were drinking fermented products all the way up into adults. And these are like maybe 4%, 5% things at the most, but they were rendered safe. And maybe not like safe by our modern day standards, given that it's still like using spring water and possibly contaminated sources, but that alcohol created a safety barrier. Okay, we touched on that. Okay, so Mr. Takamine is super cool. This gentleman came around in the early 1900s from Japan and kind of threw the whole fermentation market through a loop because he used Koji to essentially make an equivalent of barley malt, which is what we were talking about earlier, making that starch more available, more into sugar. So much so, and he was so successful, and it made such a tastier product, supposedly, that he got constantly thwarted. He had a factory burned down. He had a lot of people against him because people did not like the idea of making whiskey with Koji. It's like, we got to make whiskey the old-fashioned way. That's the only way to do it. And this was actually yielding a more complex flavor because Koji is adding flavor. It has a myriad of enzymes that are actually coaxing out a more complex amount of flavor. And so it's just worth looking into this guy's history a bit. He definitely helped popularize Koji to some extent at the beginning, and actually patented this Takamine diastate, which is a stomach aid made from synthesizing parts of Koji, which is kind of just harkening back to how Koji is going to be good for these digestive processes. It's going to be good for turning a lot of these nutrients into more available nutrients. So worth looking into his background. I need to do more reading on him, quite frankly, because it seems just like a total boss back in the day, just kind of doing what he wanted and like going against the current. So yeah, super cool. Okay, this is probably one of those studies that blew my mind. Oh man, that's like pun not intended. That's horrible. But I really apologize for that. No. So this study is really important because there's after the bombs dropped in Japan, there's this hospital, and they realized this on a certain floor, people started leaving earlier. They started not having the same symptoms as they did before, and the main difference that they found out was that they were drinking unpasteurized miso. Super cool discovery that then they actually did an actual study on. So this is a this is a scholarly article. This is something that's been peer reviewed. This isn't like a just a newspaper article. And they essentially found that the miso, specifically unpasteurized, because that's killing away the bacteria, is actually providing the perfect slate for the specific lactobacillus to come in later that's known for chelating radiation from the body. This is huge, and which is why we also encourage people to make their own miso, because you really can't get miso at the store that isn't pasteurized. And so this could be a medicinal thing for New Mexico, being that we have literally the atomic bombs being dropped, the Trinity site, Los Alamos spraying who knows what into the air. So we want to make sure that we are potentially meeting these toxins with something that can help us chelate it. Now, when Chernobyl happened, it actually became a government policy to get pasteurized miso for the people and have them eat it and drink it to help them chelate this stuff. So, we might need to do it from a grassroots level here, but why shouldn't the government maybe subsidize, maybe it is not always necessary, but could be very useful to subsidize some healthy food for the people so that we can actually not suffer the same consequences of the radiation and toxins that we're being exposed to. So just super, super healthy food. This stuff is being used from digestive issues to skin issues. It's wild, the applications that Koji has. So if you didn't get it, want a chance to scan that and get the article now, leave it up a little bit. Anyone need it some time? If not, I can always share it with you later. Okay. So let's go ahead. Okay, so Koji today, this is probably going to be a little approximative, but it's some cool little factoids. So there's this Moyasiman, it's a manga. I haven't really watched it, but it's just a good indicator that Japan really cares about their microbiology, their fermentation. The whole series is about a student in high school that can read the minds of microbes. And he interacts with all these different things that are like everything from wine yeast and beer yeast to Koji. And so it just goes to show how their whole society is more geared towards understanding these things and acknowledging this world of microbiology that we can't see with the naked eye, but we can with a microscope, or sometimes we see it but we don't acknowledge it. Their society is already primed to acknowledge these things, and I think it's super cool. Koji is also the national mold of Japan. The U.S. does not have a national mold, I can guarantee you that. But it just shows you how much they care. Again, it started in the Henan region in China. If you know a little bit about the history of the area, the imperialist nature of Japan tends to do a lot of this, taking cherry picking from a lot of the cultures that are on the mainland and bringing it to Japan and just doubling down on it. And so they did a lot to Koji. But there's a lot of other Koji cultures around the East that are totally worth exploring, and we'll touch on some later. Okay, so citric acid production. This is kind of random, so there's this Aspergillus niger. It's a close relative of Aspergillus oryzae. This actually produces 1/5 of the global output of citric acid. We all know there's citric acid in lemons, but did you know that this mold could create it and concentrate it in such a high quantity that it makes sense to cultivate it specifically for that? That's wild. And this is not toxic. It is not black mold, even though that's kind of like what's implying. It's a totally different species of mold than the Stachybotrys tractatum, which is our botulism, right? And so this is totally fine. Some people tend to freak out. They see mold-derived citric acid and they don't like it. Yes?
I was going to say that I've had people say, like, there's all kinds of different veins on the internet of like health consciousness and stuff.
I've seen a lot of that.
Yeah. And I use citric acid in canning, but I also use it for a lot of cleaning in my house because I have really hard water. And I've had people be like, that's made from black mold. And I'm like, that's actually not how it is, but I've never seen it.
It is, 1/5 of it is made from a black mold, but it is not the black mold.
No, and also by the time it's synthesized, like what's left in that product right there?
It's literally just citric acid.
Okay, that's what I thought.
And it would be a concern if it was a mold that had toxins in it, but that wouldn't be allowed either.
Right.
It's under high scrutiny. There's so much of this going into the global market that they're growing a species that doesn't contain toxins. It's a scary thing to hear. It's like it's made from mold. We all, demonize mold, and for good reason. There's a lot of sickness that can come of it, but it's like taking a whole group of all felines are bad, like lions to cats, and now all of them, it's just like a big overarching statement.
Okay, great. This is excellent.
This is what I use to alter the pH of my cosmetics.
There you go. It's a very pure source of it. It's a very even environmentally friendly way of doing it with that huge. I believe it's more cost effective to do this than even extract it from lemons. but because lemon is just a higher heat process, and there's different things going on. I don't know it totally, but it's crazy how much of it is involved in. And this is a cousin of Koji, which Koji already has so many applications, so we'll see it later. But yeah, we can go ahead. I don't know if there are any other questions before we went on. Okay. Yeah, this is a lot of words, but this is kind of like just to throw up here all the different studies that have been done with Koji, and it's really cool, the farm applications for it. They're feeding it to tilapia, they're feeding it to chickens, and they're seeing health improvements. We may not be those things, but we're clearly related as we were just talking, and so it's a good indication that it will also help for our gut. And so I really suggest that if you have chickens, it could be as easy as soaking your grain for 1 or 2 days with a handful of Koji in there. It makes that grain more accessible, and all of a sudden those chickens are getting more nutrients out of their grains. Kobe beef, we've all heard of like really high quality Kobe beef in Japan. They have such limited space that they need to do it at the highest level possible. And so what they're doing is they're taking the sake lees, which are the solids that are left over from the sake, which still have a lot of enzymes in them, and they feed them to the cows. These cows are getting a Koji-filled diet, and they're like the top of the line of the cows. So there's another little place where Koji is. And so, yeah, I can share this whole presentation with you all if you want to reference some of these things. We can go on. Thank you. I did not. Thank you. Yeah, it's good to put timers on, y'all, and we didn't for that one, but we can approximate. But yeah, about 40, 45 minutes is what we want on that. Koji Alchemy, here's the book. If you really want to dive into Koji, there's no reason not to just give this a read. Gives a great historical context, gives very simple recipes. Koji's a very exciting thing because you're like, oh, it's there too. Oh, it's there too. This culture used it. Oh, they used it for this other reason. It's everywhere. So super exciting. Rich Sai has a great, just puts out a lot of good stuff about the topics, and Jeremy Umansky and him just kind of met in the middle. Jeremy Umansky has a restaurant called Larder. He does a lot of cool Koji stuff like Koji charcuterie. I love what he talks about in the sense of using Koji to accelerate charcuterie can provide a higher quality charcuterie in less time, making it cheaper for people. So you get a higher quality thing for cheaper, thanks to Koji. We've all seen sausage with the white fluff around it, right? That's a mold. That's intentionally put there. It's penicillium, same one that you get penicillin from. There's a lot of different ones, but that's one of the more common ones. And what it does is it protects that sausage. You encase it with that, and then that puts out its own defense mechanism so other molds can't come and interfere. If you do that with Koji, you'll get the defense mechanisms on top of the increased enzyme production, which is changing and curing that sausage even faster. And you can do that with a big cut of pork. You can do it with mushrooms, you can do it with beans, you can do it with any protein, you can do it with any starch. It's such a big application. So definitely worth following Jeremy Umansky. I believe I have some of his QR codes here later. Yeah, so Noma, we've all heard of Noma, I can see just by having the books on the table, but how many of you have heard of it before seeing the book? Okay. Super cool restaurant, named one of the world's best restaurants. They won all sorts of different prizes. And really what galvanized them making so much good food was having a short growing season. This is kind of counterintuitive, but when you get just fresh food all the time, you're really lucky and you can just use that fresh food all the time. Like a tropical climate, you're getting constant supply of freshly grown produce. You literally have just such a small growing season, it's 4 or 5 months in that part of the world. And so what you need to do is you get to get really inventive and preserve it in a way that you can still essentially sell it for a $200 dish. At the end of the day, they're getting such a high value from it too because the intention is so articulate. If you've just gone through the book a little bit, you'll see they're combining novel flavors and they're working with fermentation methods from some parts of the world, ingredients from the other part of the world, and finding new combinations that are just beautiful. I will say, just like any other high-end restaurant, there's a lot of overworking, there's a lot of burnout. So I don't want to totally glorify this scene. Fine dining often has a lot of people working at a very low wage for the sake of art and expression, and when you're in the best restaurant in the world, you're like, oh, I'm going to be here, and it doesn't matter what I'm making. There's a lot of, little circles of abuse that happen in these spots. I just want to kind of highlight that. Because of this, they are trying to change their model and become a little more production-oriented, offset some of that labor onto machines and let the chefs and cooks be more creative and start and like build recipes and that kind of stuff. So hopefully they're moving in the right direction, but just wanted to have that little side note if you want to like go forward. Another book of fermentation. David Zilber was one of like the co-authors. There are other co-authors too, but these are kind of the main guys. He's on MasterChef Canada right now, which is really cool. He got hired on by one of the biggest biotech companies too. This guy's doing stuff. And he started as a butcher in Toronto and got a job at Unoma, and then his life exploded. And he has such a cool perspective on life now because of the foods he's been able to interact with, etc. So definitely worth following on Instagram, David Zilber. Always some of them, like the most novel stuff comes from his content. Okay, shared cultures. I want to highlight Ellen and Kevin. They're in San Francisco and doing such cool small batch stuff with Koji. They are making also, we got these, right, so just some examples here: butter bean, white miso, black garlic, butter miso, chanterelle mushroom miso. They do some of the coolest thing we got, matsutake miso from them. We just like won on one of their giveaways. Crazy stuff. The matsutake is already such a rare mushroom, and to make it into a miso, it's like such a delight. So, and it's kind of also telling there's not a lot of people experimenting with Koji at a small batch level in the US. Yeah, we can go ahead. Wade Fox, this is really a guy who taught me a lot about Koji. This guy's a Koji nerd, as you can tell by his costume for Halloween one year, Edgar Allan Koji, which is very much just his obsession is something that the whole community is benefiting from because he's finding all these different ways to use Koji. And so whereas like Koji's like has a lot of applications to make miso, right? These bean pastes, these soy sauces, it's really cool to see him like insert it in honey, insert it in molasses, and give it that shelf stability and have that Koji still act upon what it's mixed with. So definitely someone worth following. Fox Among Bears is his handle, and then we'll have this.
That's funny.
Oh yeah, I mean one of the things he did was he got these like mountain strawberries, got half of them, made a jelly out of them with Koji, let that sit in the fridge for about a week. It made the flavors more complex, and then he took those same strawberries, halfway dehydrated them, filled them with their own jelly, and so now you have this like strawberry candy that's made from itself with like a pulp from the inside of itself that's been concentrated and complicated by the Koji. Just wild. So good, so good. We have like a little bag where we split one like on special occasions. It makes some really powerful stuff. So I believe he's in North Carolina. Joshua, and he actually used to work at Farm and Table here in town. He since has moved away, but he really introduced me to Koji. And he's doing a lot of these experiments with poultry, and he has firsthand experience of feeding his poultry a lot of Koji and seeing a lot of good results. And more weight on the birds, but also like shinier feathers, admittedly even like better attitudes and moods. This is all, kind of like anecdotal, and so I really look forward to like even reading more of these studies that actually show the improvements, but it's cool to see it in real life and not just be this theoretical. Kyle's here in town. I actually worked with him at the Three Sisters Kitchen, and he's doing this super cool gochujang, which is this Korean-style fermented chili paste. And a cool component to this chili paste is what's called meju, which is the Koreans' version of Koji. It's a little bigger of a diversity of bacteria. They hang up these essentially soybean and rice cakes in the air and just let it be attracted by all the bacteria that inhabit this cedar room that's been like cultivated for years and years. And then you get this fermented bean that then adds a ton of umami to this like chili paste. It's wonderful. You notice that there's a lot of analogs between Korea having their own chili. We have our own chili here. Why not use a hatch chili for the paste? Super cool application. It's bringing in the local food aspect. It's bringing in a fermentation process from one place, an ingredient from another, putting them together. Super cool. Chili Jang, definitely worth checking him out. He's not selling a product yet. He's actually fighting with the health department right now, which is kind of like what it is to be in the fermentation world right now. You kind of have to like blaze the trail. And I am still in the process of fine-tuning my HACCP plan for my soybean, which is not soybean, my pinto bean aminos. But he's kind of leading the way, and he's being asked to do a lot of extra stuff that really is kind of insane. You know, like in the beginning, they were having, we need to make sure this thing is safe, so you have to test it every day. That's making it less safe. You're introducing stuff every day. You need to just like take a step back. He's presented a lot of historical and other evidence from other states. They're a little hard-headed about it. Right now they want him to like have these like super intense microbial testing. It's pretty wild, but we just gotta thank him for kind of like spending a lot of his time trailblazing. And so, hell yeah, Kyle. Yeah, I hope you get to meet him and taste his stuff. It's great. Okay, now we can go ahead. I will lose my voice if I don't forget to drink. Okay, I'm going to talk about the enzymes in Koji. There's a lot of different enzymes. It makes up to 30 plus enzymes. For simplicity, we're going to talk about the main ones that we use. And they're gonna start to sound maybe a little complicated, but then you'll see they're just very correlated to what they do. And so first of all, that A's suffix that you see, that's just referring to the fact that it's an enzyme. So amylase, that's going to break down starch into glucose. Make something starchy like rice into something kind of sweet. You can draw that sweetness out purely with that enzyme. That sweetness is already there, and then you can evolve that with Koji. Essentially like making an amazake where you cook that rice overnight, you'll wake up and that rice will be sweet. It's wild. It's already there. You don't add any sugar, and it's sweet. Protease. These are the enzymes that turn proteins into amino acids. And we'll see why that's important in a second. No worries. Lipase, they break fat into fatty acids. This doesn't have a lot of consequence unless you have a very fatty product, and then you can get some weird smells out of there. So if you're making like something out of meat, you're going to want to make sure it doesn't have a lot of fat in there, because you could get some off scents in there. Not a huge deal, but just a good thing to know. Koji and fats works a little like unpredictably. So Koji and temperature. This gets really interesting. I think it's cool how in the microbial world, and even to some extent very much our world, temperature dictates the speed at which things happen. And as you will know in like a preservation class, that temperatures also dictate safety. And so it just so happens that these enzymes start degrading around 140 degrees Fahrenheit. And it just so happens that for something to be in a safe range, it should be about, maybe above 135 to be safe. And so you can actually get a soy sauce and accelerate it incredibly, which is what I do for my soy sauces, simply by raising that temperature. So I'm raising that temperature, and I'm essentially making a soy sauce, and instead of having it room temperature, I'm putting it in my dehydrator and having it cook for about 3 weeks. And you get what would take about a year room temperature. And a bonus to that is that you're actually able to lower the salt level. A room temperature ferment, right? Lactose are about 2.5%, right? Sauerkrauts, kimchis. To do something with protein, to do something with like fish or like beans, you want to have that way higher for room temperature for it to be safe. So maybe like 20%, maybe 15 at the very lowest, sometimes 25. And so if I'm doing it inside a place where it's accelerated, where that heat is keeping it safe, I can lower that salt threshold to about 6%. And so I'm getting a higher ratio of umami to salt. Seems very technical. It's such a cool hack. It's not essentially making the equivalent of a year-old soy sauce. That may be a little more complex. But it's a really cool experiment in warping time, essentially, through temperature. So I love that about that. Keeps it nice and safe, too. Okay, so what is umami? Who here has a really clear idea of what umami is? Want to give me a description?
Yikes. No.
So maybe not so clear.
I do have a clear, but not no.
It's a complicated term, and it's kind of thrown around. It's used for different things. Generally, it's yum, and that might be
yum,
more.
that's it.
That's probably more accurate than like what it's described to. Usually, it's kind of like savory, but savory is its own thing, right? And
It's
so,
just yum.
yeah, it's delicious.
I'd rather hear you tell us.
Here we
Yeah,
go.
no, I'm not answering it.
Sorry to put you on the spot there. I think it's a good example because we all hear it, but it's hard to like put a
That's right.
an actual definition on it. And so umami is our reaction to the amino acid glutamate. It's just a reaction to this amino acid. And why do we react like this? Is because humans have evolved to crave the things that are most nutritionally available to us. And so, like, when you sear a steak properly, that's evoking some amino acids out of that meat. And what part is the most delicious part? Is that seared part. That's because it's a signaling method for our brain to be like, oh, eat more of that. And so we can consolidate. Umami is literally consolidating bioavailability. It's consolidating flavor. It's tapping into our evolutionary need for something available. And so that's what MSG is. MSG is hijacking that same pathway. It's actually taking a synthesized glutamate, putting it with salt, right? Monosodium salt, glutamate. And it's that combo makes your mouth water. Like, there's a lot of things behind MSG. There's a lot of hysteria around it, possibly, with people maybe being a little too upset about it. At the end of the day, that's a misinformation. That's a talk for another time. There's a lot of let's just say even racist sentiments attached to the wanting to exclude MSG. I've also heard that, so there are all these terms like Asian headache that are like passed around on places.
I never heard that before.
Yeah, and so, forgive me for even saying that, but it's something that was very much part of the history of that. I have heard, though, that there are some people that might be a little more sensitive, perhaps on the spectrum, that might react more anecdotally to higher quantities of MSG. So there's nuance. But clearly it's not as part of people were thinking, it's like, oh, this is like a plan on behalf of some foreign government to mess with us. There's all these weird veins and culture attached to these molecules, which is kind of crazy. It's very simply this glutamate molecule that's reacting with our taste buds and making us absolutely love it. And so why not do that with Koji? The synthetic process, it might be good, but it's not nearly as complex. And so doing it with Koji is a much, quote unquote, more natural, maybe less intensive way of evoking that same glutamate.
We actually have taste receptors on our tongue, specifically for glutamate.
That's amazing. I bet you we could taste around for it and identify them if you know where you're looking for, actually feel them react. And I did bring my amino acid sauce, so I'll get to taste a little bit of that. Go ahead. Okay, little tangent. Again, sorry, but not so sorry because it's so cool. Who's heard of garum before? Okay, so Roman fish sauce. The main thing to learn from here is that, right, when you're trying to preserve food, you're having to, you don't have fridges, you have to get, smart with it, and salt was usually a big component of this. And when you have the Mediterranean Sea right there, with tons of fish, you want to learn how to kind of keep them stable. And you would do that by adding salt, so about 25% salt. And the main part here is these guts. What's making that whole transformation from protein to amino acid is the actual guts of the fish itself. It's digesting itself, because once you've chopped it up, you expose its own guts to its own flesh. In the same way that fish would be eating other fish and digesting those fish, it's digesting itself. It's kind of wild, it's kind of weird, but it's a cool thing to know, because what you can do is you can get Koji and those are the guts of the fish. Those are the digestive enzymes that you can kind of input. So we've made a roasted deer heart amino acid, garum technically, by using the Koji as those guts to accelerate the process. And so you can make garum out of anything, any protein, all right? It could be a bean, it could be a mushroom, it could be some animal. So super cool. A little tangent. Let's see. Yeah, you can get fish at Tallinn. And the beauty is you can use the scraps too. So I get them. You get the fish heads, the fish tails, have them chop them up for me because they can just do it really easily. You get a bag of fish parts, put it with salt. Super easy.
Recently found a fermentation vessel with fish guts in it that I didn't realize had fish fermenting in it in our dining room.
Yeah, it doesn't smell. It's crazy. Maybe initially for the first day.
I'm glad I didn't find it on my own one day.
Yeah.
I would have been terrified.
Just amongst the other jars. Yeah.
Just because I want to clarify, especially with these various processes, this is really, the impetus was preservation without refrigeration.
Exactly.
I just want to make sure.
That's what was driving, how do we get all this bounty and make it so that we don't have to eat it today,
Yeah.
And so dehydrating is a thing. But salt, being that the sea was right there, could be something that they could produce. This happened all over the place. Anywhere you have the sea, fish, and salt, and that's going to be like a recipe for stuff. And so, in fact, we have some examples
I
now.
think it's also about making it tastier. Like you want to change up what you're eating, right, and not just eat.
Totally, it's kind of crazy. All the recipes got them is put in like you put it on figs with goat cheese. And it sounds crazy, but like why not have an umami, sweet, fatty thing? So, modern examples. We have some in Spain, flor de garum. Colatura Yadishi is the Italian equivalent now. Colatura means literally like
Culture.
like droplets just dropped out. I can't actually think of the direct translation of that. Colare is to like spill out, to essentially come ooze out. Yeah, that sounds a little wild, but Worcestershire sauce. It's kind of wild, but that is made with fish. The South in Nice, France, and then there are all these other there's some in the Philippines, there's some all over the place. But these are just kind of like some of the ones more in Europe.
It means pouring. That's the English translation.
Colare, yes, pouring. Yeah, pouring out. Thank you. You can do a lot with Koji. I'm just going to give a few examples, then feel free to run with it however you want. Today we'll be making Shio Koji, but we'll be getting to that. I like adding Koji to my lacto ferments, like sauerkraut, like kimchi. It helps evolve the flavor. You can even add it to your hot sauces. Now, for the hot sauces, it's kind of interesting because Koji degrades capsaicin. So if you want a really hot sauce, Koji's going to annihilate that. I put like really, really hot peppers in the sauce, added Koji, 2-3 weeks, gone. Not hot at all, it's like a veggie stock.
But good for those of us that can't handle heat.
Totally. And I guess my argument there, though, is like it's kind of like taking a few steps forward and a few steps back. You might as well just not put that hot heat in there to begin with.
Unless it's too hot. You make something that's too hot, it might be a life hack that you put Koji in it to bring
Totally.
it down.
Totally. If you make something that's too hot, that could bring it back. What I like doing is a little bit of both. Fresh hot sauce on one side, Kojified hot sauce on the other. You get that complexity, you get the freshness, you put it together. Best of both worlds. Amazake, I kind of mentioned this earlier. It's where you get that Koji, you just mix it with more rice, water, cook it overnight. All of a sudden you get a sweet, ricey, milky drink. Often enjoyed with like a sprinkle of ginger and maybe a little bit of cinnamon. This is like the electrolyte drink of Japan. This is like their Gatorade. It's what they drink on really hot days. You might even put an ice cube in there. For the Western palate, it might be a little chunky. It might be a little funky. Chunky and funky. But very much something worth like adapting your palate to. Sometimes people might expect this like porridge style thing from it. It has more complexity than that, and I want to like just kind of like preface it with that so that you're not thrown off when you do drink it. I don't think we have a taste of it here, but Tallinn has it
You can have
all
one
the
in
time.
the cooler, right?
I do. That's all frozen right now. That's another story. Shio Koji, literally meaning salt Koji. This is a marinade. This is what we'll be making later with the Koji I brought, and it's just a very simple combination of water, Koji, salt. And you do this because you're kind of putting those enzymes in stasis, and you can marinate your protein with it. And as we'll see with the chicken, but with any protein, these enzymes will help tenderize it, which is super cool, especially if you have like a cut of meat that's really tough. We had someone like just shoot a duck, bring it over to our house, but I want to eat it now, right? And if you'll know, if you've eaten duck before, a lot of the preparations are either very slow cooked. Duck confit, right? It's in fat. It cooks very slowly to make it tender. Ducks are moving around a lot. They have a very tense muscle formation, and so we actually did a really quick experiment, and just with like even 15 to 20 minutes of room temperature soak in this, one breast was considerably more tender than the other. So kind of wild what it can do even just in a short amount of time to make things more palatable, more juicy, more tender, etc. I guess you can even add a lot of other inputs to this as well, which will probably give people a chance to do.
It's like, you're gonna say mama birding, like Pre-digesting.
Exactly, yeah. The wonderful metaphor that we love using it is it's kind of a mama bird for our food. Same with that mama bird, like pre-digest that food for the little bird, this is pre-digesting it for us. And when you offset that digestion to this life form, all of a sudden you have more energy. Your body isn't revving up to digest as much as it is with like a little Koji help. Okay, we all know this hopefully by now. Go ahead.
Well, I guess the part of that with the fermentation is like maybe you wouldn't need to add an apple to your.
Oh yeah. So okay, yeah. I guess that's a good connection. She reminded me of a part of the. So when you're making a sauerkraut, sometimes people like adding carrots, apples that have that sugar component that speeds up that fermentation a little bit. If you add koji, it'll pull those sugars out of the cabbage itself, and so you can have just a very straightforward cabbage sauerkraut, but totally accelerate it. I've had side by sides, and it's so much more active when there's koji in there because that bacteria is so small it needs pre-digestion. Any questions so far? Okay.
So if you were adding koji to a ferment, would you be using like the powdered spores or like the rice with koji?
It would be the koji rice.
Oh, okay.
And I would probably add it to any lacto-ferment at about 2% at most.
And we're actually doing sauerkraut tomorrow, so we can do that.
Yeah, just add a little bit. It's just super even cool just to see the difference in behavior of the bacteria. It's really
Like
cool.
2% of the total weight of the
2% of the total weight.
Okay.
Yeah. You probably want to add that and then total that for then your 2.5%-ish salt. Okay. Yeah, so we're going to talk about growing the koji itself. You don't have to do this, but it's not super readily available. Tallinn has it. It can be expensive, but you can grow it at home. It's way easier than growing almost anything else. So easy. And ultimately what it needs is this 86 degrees approximately. You don't want to let it get hotter than that. And a certain amount of humidity, pretty high, which can be hard for us, but if you close it off, it keeps that humidity within. We'll see once we inoculate it what that will look like. But it just takes 48 hours and you're done. Super out in the open. Most mushrooms need a very sterile environment to grow. This doesn't, it's all open air. Let's see, I think if you go ahead, we'll get the steps. Yeah. So, now we're at the point where we're kind of circling back. What you want to do to grow koji is you prepare the rice or any grain, and you can get the whole list here at this QR code if you'd like. You do it by soaking it. You first soak it so that it takes in a lot of that water. You're going to want to soak it 12 hours if it's room temperature, or if you want to be super food safe, you do it in the fridge for 24 hours. Takes a little longer. New Mexico's pretty damn dry, so you're going to want to even maybe soak it longer than that. That's what I do. If it goes past that 24-hour mark, that's okay. Maybe 2 or 3 days is a little much, but soak your rice overnight, essentially. Then you get that rice and you steam it. It's very important that we steam it because we want to create individual kernels. We don't want this to get mushy. We want the opposite. We want an al dente rice because we want to give little air pockets for that koji to grow amongst. So if we do it really like porridge, it'll become bacterial. It's traditionally used more for amazake, but it can put off some off flavors. So steaming it gelatinizes it. That's the technical term. Hardens the outside, the inside is cooked. It gives it a hard shell. The koji breaks it open, eats what's within. That's nice and like softer for it, but it's not sticking. Okay, then we prepare the spores. What we'll do is we'll mix some spores with the grain. It's a really interesting ratio. It's 1 to 1,000. So for every 1,000 grams of rice that you do 1 gram of spores. Super simple, really cool how much you can inoculate with so little. And you can even make it go further. If you really mix it in, keep mixing, you can even use half of that. It really goes a long way. And that's of dry weight. You want to have 1 gram per 1,000 grams of dry weight. Once you soak it, that'll take on some extra weight, but that doesn't matter. Yeah, and so what you do with the spores, and we'll actually see that in person. Yeah.
You're talking about 1,000 grams of the rice, is that dried before you?
Exactly. dried 1,000 to 1 gram of spores. And so we actually have some rice flour. This actually happens to be Koji flour that we're gonna put with the spores. It helps spread them out a little more, it gives them a little more surface area. That enables it to just embed itself a little more into the rice. It doesn't have to be Koji, you can just use whatever flour of the grain that you're inoculating.
We're probably coming up on 42 minutes. I don't know if it's
Yeah.
gonna take a different.
If you wanna
time
just stop it
frame
now,
than-
and then just close it, and we'll just let it sit, and then we'll bring it into the other room. Okay, then, once the rice is cooked, you actually set it out, we'll see that right now, but you want it to lower in temperature. You don't wanna shock the spores. You can be accurate and get like a thermometer and figure out what temperature it is. You want it under 100 degrees, or you can touch it. If it's comfortable to you, it'll be comfortable for the Koji. And so then you inoculate the spores, they'll be mixed in, you get that, and then you put it in your incubation station. This will be a lot easier to explain once we're doing it like physically later, but I want to at least get through the points.
You wanna do it now?
No. It was better just a more controlled area. Yeah, and then you just let it go in an incubation area. This could be your oven that's just closed with the pilot light on. That's usually all it takes. I have a system at my house. It's like an old aquarium or like a never used plexiglass aquarium type thing. I put a little seed mat in there. I get my Inkbird, which is this thermostat. Relatively inexpensive for like a tool that's so precise. You don't really need one. But if you do, this enables me to like put this, I sanitize it and then I put it in the Koji. I set it for 85 degrees. That seed mat comes on, and if it ever gets hotter than that seed mat comes off, and it will. That Koji at 24 hours starts heating up and creating its own temperature and heating the actual growing space up. And so it can't overheat itself and kill itself in the process. So we want to make sure that doesn't happen. And then you harvest it by just taking it. You can put it in the fridge. That slows it down. You can freeze it. That keeps it nice and shelf stable. And then you can also dehydrate it and powder it. You just don't want to dehydrate it at too high of a temperature, or you're killing off all those enzymes that you did all that work for in the beginning.
You could freeze dry it?
You can freeze dry, and that's probably the best way to do it. And I actually used the freeze dryer here, and it felt like it was definitely stronger Koji because it had been just isolated so well, and that freezing process is just perfect. Minimal degradation. Yeah, and then you can use it for all these like other cool things. These are examples of grow chambers. As I said, your oven can do. You can use an aquarium. You can use an ice chest. Right? The concept is that it's thermally insulated so that there's not a lot of swings. You can use a fridge. The ideal spot might even be a bread proofer because you can dial in humidity and temperature, and it could be cool to do that. I haven't found one yet to work with, but it can be a very simple setup. It can be a more complicated setup. The idea is that it's so easy. It's easier than growing a tomato at the end of the day. It may be way different, totally different, but it's so much quicker. You get to a final product in 2 days. That's quicker than most ferments. So just a super cool thing to play around with. For the oven, you can add humidity by adding just a tray of water in there with a big surface area. It will kind of keep that more or less humidity higher. And again, you can use a tray to put on top of the other tray just so it keeps that humidity in. You don't want to seal it, but you can keep that humidity in pretty effectively. Yeah, any questions? Okay. Yes, please, I'm just hanging out there. Heat source can be a seedling mat, an aquarium heater inside a water bottle, and put next to it a small crock pot that's also letting off humidity inside the vessel. A small ceramic heater that's not gonna electrocute anything, hopefully because of the high humidity, which is why it'd be ideal for it to be a ceramic one. But it can be as complicated or as easy as you want it to be, and you can just use what's around you too. I want people to ask themselves what do you already have that you could grow this in. You don't need to go and buy new things. You can just use what you already have. Okay, so here's some books that I suggest. I actually have a list here with QR codes to every single book and plus more books. But these are just some good ones. The Koji Alchemy, of course. Tsukemono I have not read, but it has a lot to do with pickling and more of the veggie side of things. This Koji for Life, nice small concise booklet, and of course Sandra Katz with the Wild Fermentation, Art of Fermentation, he touches on it. And yeah, definitely read your Noma book back to back, but don't get overwhelmed. It's a lot of complicated things. Just use it as like inspiration, and also realize that not everything works for our context. So yeah, just keep that in mind. I love that book, but it also like can throw you off. It's so like you want to just go to all these rabbit holes and try these new flavors. Ask yourself what makes sense for your context. Okay, any questions? This has been a lot. There's so many different angles of Koji. It can be used for so many different things. We know that we're going to start tasting some miso. Koji also makes myra and soy sauce, all these different things. Yes?
Okay, so I apologize for being a terrible newbie, but.
No.
So, I'm not super clear. I get how to make it, I understand this process. What do you do with it?
Yeah. So essentially, once it's grown, it's this, just enzymes, which are these keys that unlock things. So you can put it together with things. So for example, for a miso,
which they got to taste the one that we made while
Great.
we were talking about this.
It was delicious.
oh yeah, definitely. I can even pass this around. I'll pass this around so y'all can see the Koji itself. Nice and fluffy. I wouldn't super touch it. You could kind of hover over it and you can feel it's,
Smell
You can open it.
Yeah.
I would just like, because we're all gonna eat this,
Look at that.
yeah, just look at that like little window.
But going back to your question, we're gonna talk more in the second part when we make the Shiokoji on how to apply it. But you can dehydrate it, you can freeze it, you can blend it and use it right away.
Yeah, and it does something different depending on what you put on it. So with the miso, you're grinding the koji, grinding the beans, putting them together with a certain amount of salt, and letting it sit 6 months to a year. And that's slowly transforming those beans. Like soybeans are, who's tasted fresh edamame? That does not taste like a lot, right? It's just like straight carbs and protein, and that's it. That changes that same amount of protein into these amino acids that become darker and that become a little more complex and that like turn into something that's more bioavailable to us, tastes better. Not a lot of things use enzymes. That's kind of the new frontier of cooking, in my opinion, is enzymes. Realizing that we can use these other methodologies to transform flavor.
I think a good way to connect it is, so y'all tasted that miso earlier. So this is one that we made in class that was about like 8-9 months ago, and it's been, sitting at room temperature since then, in its ceramic crock. And so did you taste how salty that was? So what he said earlier about like when you're using like these higher protein items, like the soybeans, for example, he was saying you're using a lot more salt, like you were saying, like 20+%.
Yeah.
Which is why I only give you a very small amount for tasting, versus like if you were doing like a sauerkraut, like he was talking about, with just like a leafy vegetable or something like that, you're using closer to like 2% of salt. That's why it's not quite as salty in the finished product. Does that help kind of make sense?
Yeah, proteins are just more volatile. They're a lot more prone to molding and contamination, and because they're even tastier to us and the microbes that are in the air. Yeah. Any other questions? Yes.
That just went by, that's the Koji.
Yeah, that's a koji itself. Yeah, and
then
it's growing
how
on
do you
rice.
How do you store it, or?
Yeah, so
process it, or-
it could be as simple as just taking that cake out, putting it in a bag, and freezing it. Probably the best shelf life you'll get from it is freezing it or freeze drying it, because that cold is keeping it shelf stable. But you can also dehydrate it, and then you have it just stable here. I think right here, yeah, I have some barley koji. It's just like the grain itself has a koji on it. It's probably going to be maybe like a year or two, and it's going to start to degrade, but it's still very useful.
And then you can use that in your recipes just like that?
Exactly. Probably the easiest way to use it is to have it dried and powdered. It's the easiest way to add it to stuff. I even have like a salt blend somewhere that's liquid. Porcini, rosemary, and koji. Adds a little bit of complexity, a little bit of sweetness, just as is. And it can become a marinade.
So would it be perhaps better to think of koji as making an ingredient to add to other things? I mean, I know I saw the
Yeah.
recipe, like you could make croutons and things out of it, but like to get some of that unlocking mechanism is to kind of think of it as making it as an ingredient to do other things with.
It's an ingredient, it's a tool almost. You know how like an egg, you can eat an egg as like a lot of different forms, or you can use egg whites to clarify broth, precipitate all like the fats and other stuff out of there. And the egg is a tool in that situation. So koji can be seen as like, yeah, a tool and an ingredient. Yeah, and so, yes, question.
Is there always a time component when it's being used? Like, does it always need to develop?
Yeah, like a miso, room temperature miso, 6 months to a year, you're gonna wanna like let it go long. That slower development helps to actually get a little more complex. Here, do you mind pouring it? Thank you. And there's always a time component, and that's why I talk about the heat as an acceleration. That's why amazake you can make overnight. It can be pretty quick if you want it to be. Like even this chicken is probably marinating just overnight.
Overnight?
Okay.
And it's like perfect because it's like the chicken skin is actually holding it in. There's a variable of water too. Water activity is a variable in a lot of fermentation, but the more water it is, the faster the enzymes will act. So you don't want it to just be a dry crust, but you still want, don't want it to be liquid. It won't hold on there. There's a lot of nuance to this, but it can be also super easy. You can just slap these things together. This is a shio koji that's from Tallinn. You'll notice it's kind of clear. And that's because it's been clarified. It's where you can do that at home. You can get the shio that we're gonna make and freeze it, and then take it out of the freezer and let just the liquid drop out, and you'll be left with the solids in the liquid. Might be even a little easier to use. It doesn't leave a huge amount of crust on there if you're trying to like marinate something. But some people then use the shio as a breading, so they'll like marinate like chicken wings in the shio and then fry it directly in the shio later, and it'll be like a breading that was added later. And there's other like time. I can talk about other time components as well.
It's not something that you just add, complete the recipe, like there needs
Right.
to be.
Yeah, you can add it. Thank you.
Did everyone see the koji over here?
Yeah.
You can just add it last minute, and it does have its own flavor
So
profile.
it's got a lot of range.
Exactly. So there's like this example. There's this retirement home in Japan that has all their salts on the table are different ratios of koji to salt. And so you can add a little more flavor at the same time of lowering that salt component. And so if you're like trying to have a low sodium diet, it's like almost tricking you into thinking you're having more salt.
Like soy sauce.
Right. So it's like, yeah, so this is soy sauce but made from pinto beans. And I'm using koji, rice koji, so it's gluten-free. A lot of traditional soy sauce is made with wheat mixed with soybeans, and then that's fermented. This keeps it a little more straightforward.
That's how long it takes to.
Say that again?
How long did that
Yeah, so this took 3 weeks.
Is it local pinto beans?
Yeah, local pinto beans. And so it's very much like, I use my dehydrator for it with a little temperature probe in there that keeps it at 140. And that, yeah, about 3 weeks. It's a little energy intensive, so you want to really fill that up just to make sure you're maximizing it. It also helps us buffer the temperature. But it's something that you could do relatively easy, making your own soy sauce, which would like take a year. You can make it in 3 weeks. That's a pretty good exchange.
Will you share about your product and like why this is important and like
Totally.
your approach to it based on something versus what they would traditionally just go to the store and buy?
Totally.
Yeah.
And I love that Sarah's here too, because so I took this course through the Three Sisters Kitchen, which ultimately helped me concentrate my efforts on developing this product, which is a way to say, hey, we have this bean that grows abundantly here. Why are we importing an amino acid that's made from soybeans that are either not likely farmed super well? I don't want to be a total GMO demonizer, but there are reasons why GMO are bad. Mainly being that they're just sprayed more. There could be other consequences. We can talk about that later. But GMO is usually modified so that it can put up with a higher pesticide load, and ultimately could more likely have more pesticides on it. That can be a little divisive as a conversation, so I'm going to leave it at that. But the idea is to use a local crop, super abundant. The pinto bean is like a nice big juicy bean, and so it's relatively cheap. And from something that's a little tasteless on its own, you can evolve it into a very complex flavor. And
Yeah, how did y'all like that? Isn't it
Yeah.
incredible?
Yeah.
Oh,
Yeah.
yeah.
Oh, yeah.
Like my
Yeah.
mouth is watering. I didn't even taste it this time. Like my mouth is just salivating.
Hell yeah, yeah. I mean, the idea is to it's a shortcut to flavor. You can have vegetables, and you can add that, and all of a sudden they're like a protein now. you know? It's a way to make cooking and tasting really simple too, and so hopefully even helps people be healthier with their food. It's hard to make a vegetable taste really good. Not super hard, but it's like, you know, that's why Noah also got famous for having like fully plant-based meals, and they were able to do that and charge a lot of money for it because it was so tasty. And it's like a challenge to make, you know, a carrot taste like something rich in umami. You know, it's more than maybe a piece of steak, which needs some salt and a sear. So, yeah, I think it could even change the dynamic of how we cook. You know, it's also just a 3-ingredient thing. It might become a 4-ingredient thing, or I might acidify it just to make it even safer, more shelf-stable. It might help with the hazard analysis plans. And so it's just a very simple input from something super simple turns into something very complex. And you can do that with a lot of different things. This same process can be used for any protein. Again, I'm going to start experimenting with mushrooms. You know, you can actually pre-grill the stuff, so it already goes in browned, so it's already tastier. And then it has this process done to it, and then it just turns into this sauce. And yeah, again, beans, meat, mushrooms.
Parts for most of
Yeah, yeah, exactly. So I'll get to just in a second. No, of course. So this is also a huge part in food waste. You can take a lot of these scraps and use Koji to turn them into gold. So at Los Poblanos, I used to work there. I have the hookup with the chef where every once in a while he's like, yo, we got like 100 octopus beaks, which are just like the bone remnant part of the octopus. And first of all, I don't super like eating cephalopods out of all the animals, but at the end of the day, people consume them, and I'd rather take that waste product that was just going to go into the compost and actually, before it even makes it to the compost, turn it into another food. And so I took like essentially a 5-gallon bucket of these scraps, and I even had some other fish parts in it. It wasn't all octopus, but it was just like a scrap bucket, but that had instantly been frozen, so it's food safe. And I take it, put it with salt, Koji, room temperature, and bam, I've got like essentially 3 gallons of this octopus sauce that can bring flavor to hundreds, maybe thousands of dishes. And so why not do that? So one of our things that we're going to try to do is actually go into restaurants and first offer some pro bono services. Like, this is how you could divert some of your food waste. You'll make more money. And at the end of the day, like, it can be a flavor thing, it can be a money thing. You're diverting waste. Why not work with Koji? Why not work with Koji? It's such a life hack at the end of the day.
Okay, so,
yes.
With the soy sauce, with the pinto beans, I just want to make sure I understood it. It's pinto beans, Koji, and water.
And salt. Water and salt. So yeah, there are the 4 ingredients there, and then plus potentially acidifying it, either with citric acid or with sumac, which like might be its own other local ingredient that might add acidity and complexity. And then I find that some people expect maybe a little bit of sweetness in there. I don't know if I want to do that. The Koji adds its own little hint of sweetness anyway. But just to keep it.
I'm a big zero waste person. And so what's fascinating to me about that was like the ease of the ingredients. So that's why I asked about that.
Totally.
And just wanted to clarify. So thank you. I appreciate that.
Yeah, of course. Go ahead.
Is there a recipe someplace for this?
Yeah, so I mean, the Noma Book of Fermentation has a lot of recipes for these. For making this
sauce?
specifically, it has the delineations for a sped up
It's
guide.
also his product.
No, I will totally share this. I will totally share the process. This is like, I'm not super concerned. People want to go find it. It's literally in the book, but my specific process, I literally follow the Noma Book of Fermentation for that. Yeah, it's the ratios. That is one thing. I guess. Yeah. So no. It's totally fine because it's variable. It's always going to change, and you got to like work with it. Like depending on the bean, how the bean was grown, it's going to absorb more water. So, generally speaking, I do 1 part Koji. I do 4 parts protein, and then I do approximately 10 parts water. And then of all of that, I take the total and I do 6% salt. But like sometimes I do it with mushrooms, and they absorb the water a lot more, making it a lot thicker viscosity, slowing the process down. So I would add more water to that, and then maybe reduce it later. So there's a lot of variability. So I'm not super worried, and I don't think anyone here is like gonna. If one of you starts an amino acid product, I'm actually happy. Like honestly, someone needs to like do it, and
There's not
happy.
enough time.
There's not enough time to do all these different things. Very happy for there to be teamwork, whatever. Like this should be. I think there's a lot more impact I can make by teaching people how to do this on their own than necessarily selling a product. It's very much like kind of circumventing, for now at least, like, you know, the complexity of the health department and all these different things, and actually getting to the source of people, helping people make it on their own. I found a little more value in teaching it, and I hope to sell a product one day, and I'm building towards that. But I think the value of teaching it to people and getting people to do it on their own, way more impact. So any questions, we'll happily answer them indefinitely.
Have you ever done anything with garlic?
That's interesting. Garlic, I have not. Garlic can be. I mean, I've made a garlic veggie stock with all the other veggies with garlic in it, and then use that as the liquid for the amino sauce. Instead of water, I use veggie broth, and all of a sudden it just has a whole other level of flavor to it. My favorite thing to do with garlic is garlic and honey. One of the safest ways to do it. Garlic is one of the most things prone most to botulism, so because of that, honey helps keep that acidity immediately where it needs to be. And so, I love garlic.
Do black garlic.
Oh, I do black garlic, that's true. Are you guys talking about black
Yeah,
garlic?
they actually did it last class, and we're gonna taste it tomorrow.
Awesome. That with the machine, right? Oh, such a cool machine. It usually takes months to do that process, and this machine, through what is ultimately like mathematical calculations of waves of temperature, is able to speed that thing up. Super cool. Yeah.
I was just curious if because garlic has an antimicrobial property to it,
Totally.
if that would.
So that's a good
potentially
question, but the thing is, we're not totally working with microbes when we're doing the heat process. There's actually just enzymes, which is interesting. If you're doing a room temperature ferment, yes, there is lactic acid bacteria in there. There's other bacteria that might be inhibited by that garlic. And so,
It is 1:37,
Yes,
so just to
let's-
be respectful of your
no,
time.
totally, let's get over there and.
We'll segue.
Indeed. If you want to link up with us, we're most active on Instagram, but you can also join our email list, and we send out monthly emails, mostly reminding people that there's these mushroom meetups coming up. They're 100% free. You show up, and we do a little bit of education, and then half of it is mingling and talking with other people. There's a whole ID table.
Potluck.
It's potluck style. Everyone brings something. It's a little party. We do it at Bow and Arrow for the most part. They let us use their loft for free. It's a super cool spot. And so, definitely suggest going to that if you're interested at all in mushrooms or that whole world. A lot of educators there that will help you find out more. And also feel free to reach out to me at that email if you have any questions for Koji and stuff. I'd gladly help further that.
We're gonna try to do more classes in the community, so that'll be a way to follow along. Koji classes, fermenting, food waste,
Yep.
everything.
Exactly. We just did the last mushroom meetup was a food waste oriented mushroom meetup. So we're trying to keep it diverse. There's going to be a lot of overlap with other themes and stuff, so could be something for everyone. And I think at this point we're going to get over to the other spot, inoculate some Koji, and make some Shio Koji.
All right, we're gonna head back to the teaching kitchen if y'all wanna go ahead and make your way back there.
What is your name? 'Cause
Julian.
Julian?
Yes.
Julian.
What's your name?
I'm Lori.
Okay, good to meet you.
I think I was coming down the hall when they introduced you.
Yeah, no worries. No, I mean,